Your Module 5 Stat Lab will be looking at correlation using the Lexical Decision Lab. This lab should take about 30 minutes. Make sure that you've read the first part of Chapter 14 on correlation prior to engaging in this lab. You'll see some background information before you start your trials. There's 120 trials, and your task will be to look at a target stimulus and determine if it's a word or non-word. And your reaction time will be recorded for each of the trials. After you complete your 120 trials, you'll get your standard questions section. Pay particular attention to this section in terms of the variables involved, as well as the prediction. You can, of course, calculate Pearson R correlation by hand using StatLab, although I recommend doing it in Excel. So you'll want to go to your trial-by-trial data. You'll see that there are 5 columns of data that you want to copy into Excel. Make sure you have 5 columns highlighted in Excel and press paste. Stimulus is not relevant to this assignment, so you can go ahead and delete that. We're also only going to be focusing on the word condition for this assignment and not the non-word condition. So we need to go ahead and sort our data. Under the Data tab is the Sort button, and you want to sort by condition. Now I'm actually going to delete the non-word condition from this spreadsheet, just so that all I have is the data that I need for the assignment. So I highlighted all of the non-word condition information, right-clicked, and then pressed delete. So now all we have are the data for what we need for the paper. The paper will ask you, of course, to begin by providing context for the paper, identifying your variables and your predictions in terms of hypotheses. The second step is visual representation of the data, and for a correlation, that is a scatter plot with a trend line. So I'd like to show you how to do that in Excel. Under the Insert tab is where we have our graph options. So you want to select your data and press the scatter plot button. You want to select the simple scatter plot. And you can add a trend line, excuse me, you can add a trend line by going to Chart Element, Trend Line, Linear, select the linear trend line. The trend line will help you interpret your correlation ahead of time. A trend line that rises from left to right indicates a positive correlation. A trend line that drops from left to right suggests a negative correlation, and a trend line that is flat, or basically parallel to the horizontal axis, suggests no correlation. In this scatter plot, we have age of acquisition as our horizontal axis, and we have reaction time as our vertical axis. So each one of these dots in the scatter plot represents the intersection of 2 points of data. So for example, for my 120th trial, the age of acquisition was 417 and my reaction time was 696. So that's about right here. So each one of these dots, there are 60 dots here, represents the intersection of 2 points of data. You can then copy and paste this scatter plot into your paper. You'll be asked to interpret the scatter plot in terms of positive, negative, or no correlation. The next step, of course, is to actually calculate the correlation and interpret it in terms of the hypothesis. So let me show you how to do that in Excel. Let's see, under the Data tab, Data Analysis, there is an option called correlation. So if you select that option, it will ask you for your input range, and you want to, of course, select all of your data. And this is going to appear in a new worksheet. Excel is telling us that the correlation between AOA and reaction time in my data set is 0.43. The problem with Excel in terms of running a correlation is that it does not provide you with a probability value. So it's hard to determine whether or not to reject the null hypothesis or not. So we actually have to do a bit of a workaround. And it's also a good introduction to regression, which you'll be seeing later in the course. Regression is just basically a more complicated version of correlation. So what we're going to do is actually run a data analysis with regression. And it's going to ask you for two inputs. Your input range, your input Y range should be your reaction time. So you can select all of your reaction times. And your input X range is going to be the AOA values. So you want to select all of those. And you can just ignore all of these things and look for the new worksheet. Press OK. Now again, regression is something that we'll be looking at later in the course. The thing about a regression is that when there are only two variables, it's exactly the same as a correlation. So again, notice here that our output, the correlation is identical. It's 0.43. And the advantage of running this in regression is that we're actually provided with a probability value. So that's why in Excel we are doing a workaround here in order to get our probability value. So if I were to write up this information for an APA report based on what's in the textbook, the symbol for the correlation is R, and the actual correlation is positive 0.43. You see that's here. I believe it's also here. And the next element, let's see, let me get there, is the number of observations. So we know it was 60 trials, right? And we see that here. All of my italics are, there we go. And then we want to report the probability value. And we find that here. This is 0.0007. Missed a no. There we go. Okay, so that is, for my data set, that is the correlation, the number of observations, and the probability. The textbook also refers to two tails. You can include that if you want. But what's really important here is the actual correlation and the probability. And we know that any probability value that's less than 0.05 suggests that we should reject the null hypothesis. So that is what we're seeing in my data set. Is there any other information? I think that covers it. Basically, you want to use the regression feature in an Excel only to get the probability value. Unfortunately, the standard correlation command in Excel will only provide the correlation itself, but it doesn't provide you with that probability value. So you have to do a little workaround using regression and just remembering that the multiple R here is the same as a correlation, as the actual bivariate correlation, and you're able to then pull in the correlation value, the number of observations, and then the probability value to interpret your correlation against the null hypothesis. If you have any questions, please contact your instructor. Thanks.